Welcome to Share Science. Over the last few weeks, we've been nerding out on the power of magnets. If you haven't already seen them, you should go back and watch the first video in the series, which we've linked in the top corner. Today, we're bringing it back from the unbelievable mind-reading abilities of magnets to the everyday data storage. For decades, magnetic storage has served as the backbone in state-of-the-art computing. And while solid-state technologies are making inroads through mobile platforms, the truth is hard disk drives and the magnetic media that power them still store the large majority of the world's data. Let's log in and find out how. Before we can get into the role magnetic media plays in storing the world's data, we have to cover a few key terms first. First, we'll look at the spindle and actuator, which are the parts that move inside the drive to access the stored data. Next, we'll dive into the platter technology, where all the digital ones and zeros are actually stored. Finally, we'll zoom in on the tiny head on the end of the moving actuator that's known as the read-write head, which is where the magic happens to move the data back and forth. Let's find out how. First, we're going to focus on the moving parts inside the hard disk drive. When you start up a regular hard drive, you can typically hear a whirring sound followed by some clicks as the drive initializes, which are the sounds of the spindle and actuators. In order to see what's actually happening, we removed the screws, and this is what you find inside. The spindle starts turning, which causes the whirring sound, and the actuators registering across each of the platters causes the clicking sounds as the data is accessed. Let's take a closer look inside to see what's actually going on. As we pull the drive apart, we can magnify the individual platters to see what they're made of, which are actually tiny grains of magnetic metal that coat the surface. As magnetic fields are moved across the surface, these grains can be magnetized in one direction or the other, which can then be interpreted as bits of data by your computer. More specifically, the magnetic direction of an individual bit can be accessed directly by the read-write head that we'll look at more in depth later. The important thing to know for now is that as data is being written, the magnetization direction can be switched in one of two directions to correspond to a 0-bit or a 1-bit. Later, when the data needs to be accessed from the drive, a magnetic sensor can scan over the same area to read the data back to the system. Furthermore, the head does all this while flying just nanometers above the platter surface at speeds upwards of 75 miles per hour. A truly amazing feat of technology. Now, this approach worked great for decades until the information density came up against what's known as the super-paramagnetic effect, where the bit size got so small that neighboring bits would start interacting with one another spontaneously, which means loss of data. What was needed to stabilize these bits was to transform them from horizontal magnetic domains to vertical ones, which enabled the information density to increase tenfold to an astounding 1 terabyte per square inch. Let's take a look at how this perpendicular technology works. In this technology, the write head generates a magnetic field that pushes down into the media to create a bit size approximately 100 nanometers on each side. A pulse of current runs through a coil of wire inside the head to generate the magnetic field that travels down and orients the magnetic domain either up or down. Now, unlike the horizontal media, this orientation alone doesn't correspond to a 1 or 0. Instead, adjacent domains that are opposed will generate magnetic flux that can be measured outside the platter. And that is what gets measured to indicate a change of state in a read cycle. While we are here, let's take a closer look at the read head, which is actually a pretty advanced bit of technology. Opening the case, we see the sensor is a stack of alternating magnetic and non-magnetic materials. This creates a device with what's known as giant magnetoresistance, or GMR, for which the electrical resistance is very sensitive to any change in magnetic fields that pass through it. As bit orientation changes are measured, the resistance in the head changes, which can then be converted into the data that's written on the platter. The system keeps track of the process by organizing each platter into sectors of data. Each sector includes a preamble zone and address that indicate the location and size of the sector on the platter. followed by the data and an error-correcting code, which is used to cross-check against any readout errors that may have occurred. So now that we understand how data is stored and accessed inside a hard disk drive, how is it used to store data we access over the internet? Data centers like the Citadel in Nevada string millions of hard drives together into servers that are installed in racks over millions of square feet with all of the power and cooling requirements to keep things humming. How much data can one of these data centers hold? Well, with a footprint of 7.2 million square feet, a data center like this one can accommodate over 230,000 racks, accounting for a whopping 1.8 zettabytes of data. How much data is that, you ask? Well, to use our generous benefactor YouTube as an example, which generates around 5 petabytes of data every day, a data center this size would take 1,000 years to fill up. But YouTube isn't the only one generating content, so data centers like this one are being built out to make sure we have enough storage to remember everything we need for many years to come. To summarize, we covered the amazing way magnets are used to save huge amounts of data via magnetic hard disk drives. The moving parts of the devices are the spindle, which spins around at speeds up to 75 miles per hour, and an actuator that floats just 5 nanometers over the platters to read the data out. The technology to interact with the tiny bits of stored data is called the read-write head, which uses advanced technology like giant magnetoresistance to enable data densities upwards of 1 terabyte per square inch. By aggregating such drives into servers by the millions, companies like Amazon and YouTube can store and serve data to millions of customers simultaneously across the globe. We hope you liked today's video. If you haven't already seen them, you should go back and watch our previous installments that covered where magnetism comes from, how it's used in electric motors, as well as the magnetic technology behind MRIs. If you liked this video, hit subscribe below and you can get new content just like this every week in your feed automatically.